Calorimetry and Q equals MCAT for thermochemistry day 2. After today, we should be learning about what a calorimetry is and its function, explain what temperature change is and it's dependent upon, and also specific heat, and use the specific heat equation of Q equals MCAT. So a calorimeter calorimetry is the accurate and precise measurement of heat change for physical and chemical processes. So if you think of a calorimeter, it's basically like a device that's going to measure how much heat is being absorbed or released. So think of your styrofoam cups as an example. Whenever you're drinking your favorite beverage, you want to be able to see how much heat is being transferred from one object to another. So let's talk about a coffee cup calorimeter and a constant pressure calorimeter. So if we take a look at this cup, there's a thermometer that's stuck through it. The thermometer basically is going to measure the average kinetic energy of the molecules inside the liquid. You're going to have a styrofoam cup with a cover and then stir. The thermometer is going to record the temperature as the chemicals react in the water. And the temperature change was then going to be converted to some sort of units of energy that we can calculate. So it's very important when you look at this is that you want to see how much energy does that water absorb. Now, a bomb calorimeter is very similar, except that we have this object in which we have a sample in this little cup. We're going to ignite it with these ignition wires, and it's going to release heat. The difference here is that the sample is going to be lit on fire, and it's going to be burning until it's gone. Then the heat from the sample is released, which eventually releases into the water. And that temperature change is converted to energy, which we're going to be calculating. So that's the general setup for a bomb calorimeter. And it's very important that you understand that the water is going to be picking up that energy. Okay? So temperature change is dependent upon a couple of things. The amount of heat that's being added, the mass of the substances, and the composition of the substance. In other words, the specific heat of that. And we want to know is boiling water. So if you boil water, the metal pot gets a lot hotter faster than the water. And so the question generally is, why is that the case? And it's because you have different materials that are heating up. And it also depends obviously on what the mass of that is. So let's talk about specific heat. So specific heat is the amount of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. So think of it an example as what I did in class with our bubbles, our heat. Or when you're actually going to the beach, the sand is going to be a lot hotter than the water because they have very different specific heat capacities, the ability to raise that temperature. So think of objects that generally are going to take more energy versus others that are very easy to heat up. So let's talk about the units. The units we'll be talking about today is called calories per gram times C or joules per GC. Generally, we're going to be using the joules over grams per C because that's the one we use in labs. And for water has a very unique property. It has the ability to actually hold a lot of heat, or 4.18 joules per gram per C, or 1.00 calories per gram per Celsius. So this is a very, very important number that I want you guys to make sure you know. So let's talk about our formula, Q equals MCAT. So Q equals mass times C times delta T, where Q is equal to the heat joules or calories. We also have mass, which is equal to grams. And we're also going to be getting C as a specific heat. So as you notice carefully from this, C is going to be considered your heat capacity or specific heat. And this is going to be referred to as cal over GC or J over GC. And delta T refers to your final minus your initial. In other words, your final temperature minus your initial temperature of how much it actually rose in temperature. So let's go over to the first problem. How many calories of heat are required to raise the temperature of 525 grams of aluminum from 13 degrees Celsius to 47.8, assuming that our specific heat is 0.21 calories over gram per Celsius. So the first thing we want to do is we want to figure out is how much can we move that temperature, which is quite a lot. So Q is equal to M equals NC. So we're going to start to set this up as Q is equal to how many calories, M is equal to 525 because that's our mass, and our C is 0.21 calories per GC. And our temperature is going to be 47.8 minus 13, which gives us 34.8. So if you notice carefully, It's just basically applying it to our equation. So 525 times 0.21 times 34.8, which gives us, cancel, 33,800 calories. And that's going to be our answer for this question. And we want to, understand how that number comes out. It seems like it's a lot of energy because we want to go for quite a bit. Okay, let's talk about the next one. What mass of water would have its temperature raised from 22.5 to 94.1 with the addition of 5.1 kcal of heat, kilocalories? So let's talk about Q, M, C, and delta T. So Q is equal to 5.1 kilocalories, which basically means that you have quite a bit of heat here, but we're going to have to convert this to calories. So we're going to convert that by multiplying that by 1,000, which gives us to 5,100 calories. Now our mass here is going to be what we're trying to find out. And our C value is not given, but we know it's water. So we know that's going to be 1 calorie per gram per Celsius. And our temperature is 71.6. So now we're going to plug this in. We're going to solve for mass, and we're going to divide everything by 71.6. So our mass here, cancel, is 71 grams. Okay, any questions? Go ahead and complete worksheet 2.